being here. I appreciate you taking the time out of your day to come in and help yourself. So we want to go ahead and jump into it because I don't want to waste any of your time, and I want to be able to offer you an opportunity to ask questions if needed. So let's go ahead and get started. Whether you are my student or not, we're all learning the same content. All right. So in your first unit test is going to cover modules 1 through 3. Okay, so I'm not exactly sure when everybody's test is, but it's probably by the end of the week or so. All right, so the first thing that we discussed in module 1 was we were trying to do an introduction to the data. What we were learning here is that when we start, we collect our data. So once you get that data, there's so many things that we were able to do with that data. We classified that data, okay? So when we classified the data, it was classified as numerical or categorical. Now, a couple of things that we were able to do with the categorical data, we were able to organize it using a two-way table. So the two-way table allowed you to take a look at two categorical variables and how they relate to each other. Now, in the numerical aspect, we were sorting that data. We have stacked versus unstacked data is one way that we sorted it. So we asked ourselves all those important questions. Why is this data important? Who created this data? When was it collected? How was it collected? You know, you ask yourself all of the important questions about a set of data, because you have to remember that there are always people with certain agendas that they want to push. So you want to make sure that as many of these questions have been answered, so we can start minimizing the variations, the bias that we have within that data. All right. And so that we can trust the conclusions that we're drawing here. So the two main aspects of statistics, as we learned in this module, were data and variation. All right. So when we looked at the data and we classified, then the next thing was, okay, so we want to take a look at how this data and the differences within our data, because that's one of the ways that we minimize our bias. All right. So question, let's take a look. Let's look at the poll. And what do we know about data? Are they numbers, variables, numbers in context, categories? Exactly what is data? One of those main concepts of statistics. Let's go about 5 more seconds. Okay, ending poll. All right, so 44% of you said C. And then we have 33% that said A and 22% said B. Okay, so we eliminated categories out of the data. So in this case, when you're talking about data, you're always want to consider data as numbers in context. That answer is C. Okay, you don't want to just say numbers, because that's one of the things we talked about here. That statistics is a lot of analysis, a lot of summarizing the data. So I don't want to just know what the value is. I don't want to know that the mean is 30. I need you to tell me what that represents, because that mean, the average, may or may not represent the center of my data. Okay, so that's some of the things that we talk about. The next one was variation. Variation is the next one of the two most important concepts in statistics. So variation says differences. So every time you, what happened? Went too far. Every time you see the word variation, I want you to think differences. Okay. Okay. Now, I'm sorry. Am I seeing this correctly? I got some variables. I apologize. I wrote this and forgot what I put. So it's supposed to be variables, not variation. So with variations, I'm going to mark this out. That's not what we're talking about right now. With variables, that's the characteristic that you're interested in about that data. Okay, so whatever we're interested in, whether that's that variable can be numerical or categorical, that's what we discussed earlier. Okay, so it's the characteristic that we're interested in about that data set. So are you interested in the person's weight? That will be numerical. Or are you interested in the person's gender? That will be categorical. But some of the things that we discussed in this module was that there are some times where we have numbers that represent categorical variables. Okay. Some of those examples could be your zip code, because that represents a location. Your social security number represents you. Okay, so if the value, the numerical value, if there is no mathematical process, for example, if you compare two social security numbers, what does that tell you? That doesn't tell you that one person's older or that person makes more money. Doesn't tell you any of that mathematically. If the number represents a person, place, or thing, that number represents a categorical variable. Okay, so keep that in mind, because that's definitely one of the things that students have difficulties with. Whoops, what just happened? Okay. All right, so gender, I think that's one of the examples I mentioned, so I've already given you the answer. All right, gender is a categorical variable. Then we sorted that data. Stacked versus unstacked. Stacked data can have as many variables as needed. Stacked data says each one of these rows represents one person. Okay. Whereas in unstacked data, one row does not represent one person. As you can see here, you have, let's say, for example, let's say that this represents males and this were females. So that's two different groups here. So that means that whoever's in this first row, that doesn't represent one person. Okay. So therefore, unstacked, when unstacked data, you're really just dealing with two variables. But with stacked data, I can have a lot of variables because that entire row would just represent one individual. Okay, so we're just kind of going over all the things that we do to the data, the ways that we can sort it, organize it. Here's another one. We classified it numerical versus categorical, but here's another way that we organize two categorical variables, and that's by using the two-way table. So in this case, you want to be able to answer several different types of questions regarding the two-way table. Be able to tell me the frequency, that's just how many. For example, if I stated, how many people like snowmobiles, then there's 105 of them that like snowmobiles. Well, what about the ones that like snowmobiles but do not like skateboards, where there's 25 of them? So that's the count or the frequency. Now, what percent of those surveyed like skateboards but not snowmobiles? So being that this is the percent of those surveyed, this is out of everyone we're interested in studying. There are 160 people here that were a part of this study. So out of the 160, we have to consider they like skateboards, but they did not like snowmobiles. There's 45 of them. Okay. So 45 out of the 160. Now you have to be able to convert that to a decimal. You want to make sure that you round the decimal correctly, because if not, my stat lab will mark your answers wrong. So 45 out of 160. The value is 0.28125. All right, so let's practice rounding, because I don't want you all to get questions marked incorrectly because of the rounding. So if the question says round two decimal places, Well, it didn't ask you to convert it to a percent. It just said round 2 decimal places. So therefore, your answer would just be 0.28. Okay, so remember, you're going to look up at that third number, round up if it's greater than 5, round down if it's less than 5. But then if you see this and you see a percent sign, and then it might say round 1 decimal. Well, this is a common mistake. Students will put 0.3. But that's not correct. If the question said round 1 decimal place, your answer is 0.3. But when you see that percent sign, it is first asking you to convert it to a percent, then round to 1 decimal. So when we convert this number to a percent, that's moving the decimal 2 places to the right or multiplying by 100. So once you do that, then round the number 1 decimal place. So that answer would be 28.1. Okay. A lot of questions are missed on this test, or on all the tests, because of rounding. All right, so be very, very careful there. So now, away from two-way tables, let's go back to our polls. Tell me what you think a sample is. What do you know from a sample? Oops, relaunch that code. Okay. What's a sample? A set that contains all the information about everyone or everything. B, data that is just one part of a data set. C, advertisers give to consumers to get them to try a product. Or D, a collection of variables. What is a sample? Samples are very important because that's how we collect our data. Okay, 5, 4, 3, 2, we're ending the poll. Here are your results. 70% said the answer is B. You are correct here. Okay, a sample is a subset of a population. So we're interested in everybody in the population. So let's say I'm interested in students in Tallahassee. Now, what is a sample? A sample is just a small subset of that population. So I could say TCC students. That is a sample of that population, but it's not a good sample. Okay? It's not a good sample because do TCC students represent the population of students in Tallahassee? No. Okay. If you want to get a good representation of your population, we need a random assignment. You randomly select subjects to be a part of your sample. So one thing that we started talking about in module 1 is, oh, we got something on the screen. Let me try to get rid of it. All right. We talked about controlled experiments versus observational studies. So when we are trying to establish causation, we want to make sure that we have a random assignment of subjects to a treatment and a control group. If you do not see that answer in, I'm sorry, I never answered this question, I apologize. But if you do not see the word random assignment, that's what I meant to do, underline random assignment. If you don't see that word random in the scenario, that is a key flag that it is not a controlled experiment. If you do not see the word random, you're dealing with an observational study. Okay, so we have to randomly select our sample. We place them in groups, and that allows us to minimize biases because we don't want the same type of person in each group, right? We want to minimize bias. Okay, so a random selection, that's the first thing that you need in a controlled experiment. The next thing, after we get the random assignment to the treatment and the control groups, if you don't see that, that's observational, as you can see here. We got that random assignment going. If all I'm doing is just a comparison, that's not a controlled experiment. So you want to make sure that you have randomly selected and went too far. A placebo. A placebo is necessary for a controlled experiment. Now, typically, those who are in our, not the treatment group, where's my control group? So my treatment group, control group, those are in the treatment, the control group gets the placebo if necessary. Every study doesn't need a placebo, okay? The other key thing that you want to make sure that you have dealing with a controlled experiment, you want to make sure that you have a double blinding study. We already talked about random assignments, double blinding study, placebo. A double blinding study says, I'm the subject. I have no idea if I'm in the treatment and control group, and neither does the researcher. Neither one of us know which group that I'm in. That helps us minimize bias. Okay. And the last thing, we want to make sure that we have a large enough sample. You don't want to complete a study with 10 people. You need a large enough sample. So this would be all of the above. Okay. All right, let's talk about that observational study. We cannot draw cause and effect if you're dealing with an observational study, and let me add in here, or if you're dealing with anecdotal evidence. Neither one of these can establish cause and effect. And the reason being is that we can say, oh, sun exposure, that's our input. Okay. So whether you're using sunscreen or not, or does the sun exposure itself cause cancer? You're asking yourself, well, is it the sun itself, the exposure to the sun, or is it this other variable that might be out there, the use of sunscreen? So when you have another variable that you're interested in saying, okay, can this cause my output to happen, my outcome to happen? That's called a confounding variable. It's not a part of your study, but it can affect your study. Another example, let's say a diet aid. If you're trying to determine whether the diet aid is helping you to lose weight, so a confounding variable could be exercise. Maybe that's what's helping you lose weight, not necessarily the diet pill that you're taking. Okay, so again, those are confounding variables. So because of that, observational studies and anecdotal evidence, which is your story, neither one of them can establish cause and effect. All right, that's a quick run through of chapter 1. Any questions on chapter 1?
Yeah, I have a question. So on the test, there would be like a possibility for like a question, because like a lot of this was more so like definition. Would we see a lot of that on the test? Like for example, like you would ask us what possible graphs could be used for, categorical that can't be used for numerical data. Like, would that be a simple question, or would it be, more so like the problem?
Your questions are more conceptual.
Okay.
And this should be true for anyone's class. Your questions, so I'm going to take the example that you just gave as far as which graphs can be used for numerical versus categorical. So that's what we're about to go into in module 2. But that question would more than likely not be asked.
Right.
The question that would be asked would be something like, okay, if we want to look at a graph that shows the variation of zip codes, what is the appropriate graph that can be used? So you see how you need to know that information, the question, the way you worded the question, if we're going into module 2, so we might as well go ahead and start looking at it. Here are the graphs that can be used for numerical data. So if these are the graphs, then a question that I would ask would simply be more conceptual to say, hey, if you have you're trying to look at the variation of weights, what type of graph could you use? Well, weight is a numerical variable. So therefore, I can use either one of these. Now, it doesn't necessarily mean that you should use a dot plot over a histogram. In that case, look back at your advantages and disadvantages of each one of these that was given in the lessons, but you could use either one.
Right.
Okay, so that's what your question would more than likely say, other than which graphs are for numerical, which graphs are for categorical. You're not going to see questions like that.
All right, thank you.
You're welcome. All right, I see Bailey.
My question would be, whenever we're talking about single blind versus
Blinded versus double blinded.
in our practice, like one quiz. Yeah. I guess my question being is because I remember quiz 1 that we did on our stat lab. I like got something wrong because there was a difference between single blindness and like regular blindness or something.
There's blinded study, then there's double blinding study.
Okay, but there's no single blind.
Well, a blinded study, if you're
Is
calling it single blind, a blinded study just simply says the subject does not know if they're in the treatment or control group.
Okay, and then how, if they just don't state that the researchers don't know, then you just assume that it's single blind?
Your questions are going to be more geared towards, if it's an observational study, you won't see the word random. That's kind of the key that I always tell students to look for. If it's observation,
Okay,
it will not be a randomized assignment. We're not going to, now there may be questions where you don't see that it's a double-blinded study. And if you see that it's a random assignment, but it's not a double-blinded study, then the question would be, can we establish causation?
okay.
Okay.
All right.
You're welcome. All right, so moving along in module 2, we stated that the types of graphs that we can create for numerical variables were the dot plots, histograms, that's frequency and relative frequency. The only difference between those two is one deals with counts, the other one is in percentages. That's it. All right, so a frequency histogram, you'll have counts over here, how many, whereas in the relative frequency, I'll just have maybe the decimals that will add up to a percentage once you add them all together, which will be 1 or 100%. Okay, the histograms themselves will look exactly the same. It's just that one is in terms of percent and the other isn't. And then a stem and leaf plot. Let's take a look. Here's our histogram. And in our histogram, a couple of things about it. The bars must touch. Consecutive bars must touch because numbers are continuous. Okay. You can see this is a frequency histogram, how many we have in each bin. Now my numbers here are in the middle, but otherwise we would have our bin widths, which will be what we're counting by, what numbers will fall within each interval. All right, so the histogram, again, we can use a histogram whenever we have numerical variables. Okay, in the stem and leaf plot, you have one side called the stem and the other side is the leaf. The leaf is always the last digit. So if the leaf is the last digit, then the stem can be every other digit. But the leaf is the last digit of that particular number. So therefore, in this data set, my data would say that stem, that's 13. And then 14, 16, 17, 18, and we have 12. That's all the data from that first row. Okay, because once again, the leaf is the last digit. Okay, now the stem and leaf, this you cannot do in your calculator, but you can create it in StatCrunch. Okay, so the stem and leaf allows us to see the individual data values, whereas if you look back at the histogram, it does not, because you don't know how many 132s, 131s you have in this bin. You just know altogether there's 2 of them, so you don't see the individual data values. Histograms are great for large data sets. Okay, a stem and leaf, StatCrunch can give it to you, calculator won't. It shows you the individual data values, but you don't want to use this for large data sets. Okay, so that will be a disadvantage of the stem and leaf. Okay, but you can see the shape. See the shape of your data right here. There's some skewness there, so we'll talk about that shortly. Okay. Whenever you're summarizing, I didn't show you a dot plot because that one's not widely used. You will have questions on the test where you want to read from a dot plot. But I'm going to go ahead and go into summarizing the numerical graphs. Okay. When you summarize, so we started off, we said, hey, once you get that data, it's numerical or it's categorical. So if it's numerical, then the graphs that you can create, your dot plots, your stem plots, your histograms. Okay, we haven't talked about categorical yet. All right. Once you summarize that data, if it's numerical, you're working your way through SOPs. Shape, outlier, center, spread. When you're dealing with shape, you ask yourself the question, is my data symmetric? If it's symmetric, then my left side and my right side kind of looks the same. Okay. Is it skewed? That's all under shape. Okay, I'm dealing with the socks again. Shape, outlier, center, spread. Is it symmetric or is it skewed? The next thing you want to know, how many mounds do I have? Is it unimodal like this one? I only have 1 mound, so this one's symmetric and unimodal. Is it bimodal, where I have 2 mounds? Or is it multimodal, where I would have more than 2 mounds? The next one is center. Oops. You want to ask yourself, is the center, where's my slide? Is the center the typical value? Okay. Here, symmetric and unimodal, my center is my typical value. The typical value, that's the highest occurring. It's the mode. Whereas in this distribution, that's bimodal, your center is not the typical value if it's bimodal. Your center is not the typical value if it is skewed. Okay. In module 3, we go into more detail with the calculations of center, but for right now, you just want to be able to identify if your center is the typical value. Okay. I mistakenly skipped outliers and I also skipped skewness. I apologize. So remember, under shape, you're asking yourself, is it symmetric or is it skewed? And it might not be either one.
So
The distribution is right skewed if it has a tail to the right. So you name the skewness by its tail. A distribution is left skewed if it has a tail on the left. So as you can see with the right skewed distribution, can I get everyone to mute, please? Thank you. If most of your data is on the left-hand side, you have a tail to the right. So for example, what type of distribution would that be? That could be the distribution of a very difficult test, because you would have a lot of students on the left side of that graph because they didn't score very well on the test, and you won't have as many on the right. Now, this left skewed distribution at the bottom, in this case, that could be an example of a very easy test where most students scored high and then very little scored low. Okay. All right, so these are the questions that we asked under shape. Next question, outlier. We've already dealt with that. When you're dealing with an outlier, you're just looking for, is there a data value that's kind of far off, doesn't really fit the data? Now, the thing about outliers is there is no precise definition for outliers. So you would hear us say, this is a potential outlier or possible outlier. And sometimes an outlier in your data could just be a mistake. So in this case, our answer would be all of the above. Okay, it doesn't fit the rest of the data. It could be a mistake when you entered it in. It could be correct, but it has no precise definition. Okay, so that's why you see potential or possible. So now we're continuing going through SOX, shape, outlier, center, spread. So now we're on the spread, the last S. Whenever you're dealing with spread, I want you to always look horizontally because you only have one variable, and your variable is always along the x-axis. Your y-axis is always frequency. So therefore, you always look horizontal to determine your variation or your spread. Okay, same, you can use either one of those terms interchangeably. All right, so which one of these, A or C, has the greater spread? Let's see if I have my poll. A or C? Well, I don't have a 2-option poll. Not for this one. So then let's just talk about it. Now, when we're dealing with spread, we're trying to figure out, where's majority of my data located? Is it located in the center? Because if it's kind of located around the center, then I would have a smaller spread. But if I have a lot of data that's not as close to the center, then I have a larger spread. So C, in this case, histogram C has a larger spread than histogram A, because in A, you can see that most of the data is close to that center where our typical value lies. Okay. So that's SOX. That's for numerical variables. All right. So remember, data classified numerical or categorical. Next, we talked about the graphs. So we did dot plots, histograms, stem and leaf plots. And then when we summarize it, we said summarize using SOX. But if it's categorical, you're able to create a pie chart and a bar graph. Okay. Now, a Pareto chart is a type of bar graph. It just puts the bars in order from the highest frequency to the lowest frequency. So if the test question asks you, I think it was it Alexis that asked that question, if I'm not mistaken. If the test question says, I think I gave the example of, you want to show the variation of zip codes, that's a categorical variable, or show the variation of colors, that's a categorical variable. So therefore, when you're dealing with those categorical variables, what type of graph can you visualize that data with? Pie chart, bar graph, or Pareto chart, because it is a bar graph. Okay. All right. When you're talking about your pie chart, of course, you're trying to make a comparison to the whole. And in a bar graph, make sure you know the differences between the bar graph and the histogram. Remember, we talked about in the histogram, the bars must touch. In a bar graph, you're dealing with categories. Do you see these letter grades? The bars are not touching because you can't have an A and a B. Okay, there's no consistency here. Okay, so categories are not continuous. That's the word I was trying to state. They're not continuous. Numbers are. So that's why we don't have any spaces between the numerical data on histograms, but we do with the bar graphs. Okay, so that's one of the key differences between the two. So pie charts and bar graphs. All right, so the question says, a bar chart or bar graph is the exact same as the histogram. So this is what we were just talking about. That would be false. A histogram is a type of bar graph, but it is for numerical variables. not categorical variables. Okay, so they are not the exact same, even though a histogram is a type of bar graph. Okay. When you summarize categorical variables, so we just looked at the graph. So if it's categorical, we said bar graphs, pie charts, and of course, Pareto charts are included in there. So those are the graphs that we would use. When you summarize it, you only talk about the mode and the spread. Those are the only two. You cannot use SOCs with categorical variables because you have to think about it. Because it's a bar graph, I can change, let's go back to that previous slide. I can change the order of my categories. And if I change the order of my categories, then how do we determine what the shape is? If I make this a Pareto chart, my largest is China, then my next largest is India, and then France, and so forth. So if I can change these categories, and depending upon who's graphing it, we can all have different graphs, then we can't use SOCs because that means we would need a shape, and we won't all have the same shape. Okay, so all you want to discuss is mode and spread. Now, there are some differences when you're dealing with unimodal, bimodal, or multimodal for categorical variables. If you recall, I stated earlier that for numerical variables, the mounds do not have to be the same height. But now I'm going to tell you for categorical variables, those mounds must be the same height. And you might say, well, why? Because think about it. If we were to look at a bar graph between every single bar, every one of them will be multimodal. If we were to consider the bars not having to be the same height. So therefore, we're looking for the mode. Where are my typical values? And in this case here, my mode is car. That's the typical travel choice. But over here, when you're dealing with the subjects, if you notice, these two are very close together. So this would be considered unimodal, but this would be bimodal because the bars are roughly the same height. Okay, so that is how we look at mode for categorical variables. Spread. I want you to think of spread when it's dealing with categories. Think of it as diversity. The more diverse, the higher the spread. Okay, so if I have many, this is what I want you to remember right here. If I have many observations in many different categories, then that gives me a high diversity. I have a lot of diversity. So then variability is low, that would be false. My variability would be high because I have a high diversity. Okay. If I have a lot of categories, but most of my data lies within one or two categories, then that means my spread or my variation is low. Okay, so mode and spread is the way you're going to summarize categorical variables. Okay. The last thing in this module we talked about was misleading graphs. One of the ways that you would make your graphs misleading is if your y-axis did not start at 0. So as you can see, this is exact same data here. However, here with the graph starting at 0, when you look at the differences between A, B, and C, all right, you know, it's not that big of a difference. However, when your graph does not start at 0, now it appears to be this huge difference between the number of A's and B's and C's. So therefore, you always want to make sure when you are reading graphs, this is a common trick. When we talked about it earlier, when folks are trying to mislead you, then this is a common trick that can be used. They want you to believe that the differences are a lot greater than they actually are. Okay, so be careful when you're reading graphs. All right, so that's module 2. Oh, this is the other thing I wanted to show you with the bar graphs. Another way that our graphics can be misleading is because our eyes always insinuates to the larger area. So since our eyes kind of go to that, we would think, if I were to ask you the question, you know, which bar was the greatest? Bar 2. No, it's not. It's not. It's bar 4. It has the highest frequency. But because our eyes are gravitating towards area, that's two-dimensional, when it should just be the height, which is the frequency. That y-axis tells me frequency. So when you're dealing with bar graphs, you want to make sure that your bars are the same widths. So that is another thing that could be misleading. Okay. So make sure that if you're trying to compare frequencies, the only things that are different would be the heights of the bars, not the widths. All right, any questions on module 2? Module 2 took us through visualizing our data. So module 1, we collected, we sorted, we organized, we used two-way tables, and we determined whether we can establish causation or not. Then module 2 says, now that you have this data that's been classified, organized, etc., now let's visualize it so that we can see the variation of the distribution. We can see the patterns. Okay. Module 2 questions. All right. So on to module 3, the toughest module of the 3. Here, we're really breaking down center and spread. So remember, when we're going through SOCs, shape, outlier, center, spread. This is where we calculate and interpret, all in module 3. Now, I know if you're in my online classes, you guys are still working in module 3, but my in-person classes were finished. So I'll probably be teaching you or showing you some stuff that you don't know, but you can always come back and view it later if necessary once you get to that section. All right, the very best, and remember, we only use SOCs when we have numerical variables. So when we create our graphs and it's time to summarize and interpret, we use SOCs because my data is numerical. So in this case, when you get to shape and you see that the shape of that distribution is symmetric, your very best measure of center is the mean, the average value. The best measure of spread is standard deviation. So S, or S of X, is the variable for standard deviation. If that distribution is skewed, the best measure of center is the median. And the best measure of spread is your IQR. Okay. So the median is the number in the middle. The IQR represents the middle 50% of your data and can be calculated by taking your third quartile and subtracting your first quartile. So dealing with standard deviation, by definition, the standard deviation is the distance a data value is away from the center of the distribution, which, if it's symmetric, is the mean. So given that information, which one of these has the smallest standard deviation? If the mean represents the center of a symmetrical distribution, and each one of these, that one's symmetric, left side equals right side, is symmetric and bimodal. This is symmetric. This is called a uniform distribution because it's kind of flat, rectangular. And this one's symmetric and it's unimodal. So they're all symmetric. Okay, so now we're talking about the center of our distribution. The mean represents the center of the distribution if it's symmetric. Standard deviation represents the distance a data value is away from the mean. So if I want the smallest standard deviation, if standard deviation represents distance, and I don't know why this is writing in red when I selected blue. So let's try that again. Still in red. 1 second. Okay. Since it represents distance, if I want a small distance and standard deviation says, how far are you away from the mean? If I want a small distance away from the mean, shouldn't that mean I should be close to the mean? So the distribution that has a small standard deviation will be the distribution where most of the data is close to the mean. So in that case, my answer is C. Most of my data is in the center of the distribution. It's close to the mean. So this distribution has the smallest standard deviation. Standard deviation, again, is a measure of your spread, and it is best used when the data is symmetrical. It best estimates the spread of a symmetrical distribution. Okay. Now, which one has the largest standard deviation? So standard deviation, again, is distance. So if I want the largest distance, that would mean the data is farther away from the mean, which is in the center. Therefore, A would have the largest standard deviation because a lot of the data is away from the center of the distribution. Okay. All right, so be able to calculate when I finish reviewing everything, I'll remind you all how to do all your calculations in the calculator as well as StatCrunch. All right, the empirical rule.
Excuse me?
Yes.
I might have misheard you, but the order for that last one from like smallest to largest, the standard deviation from the center, it would have been C as your closest, like you said, and the second closest was A, you said, or it was B?
No. I answered smallest and then I asked which one was the largest. So C is the smallest standard deviation, then B, then A. A has the largest standard deviation.
All right. Yeah, just want to make sure I was right. All right.
And I guess I should explain B. B, you do have a lot of data around the mean, but you also have the same amount of data approximately away from the mean. So that's why B has a smaller standard deviation than A does.
All right, perfect. Thank you.
You're welcome. All right, the empirical rule. This is the key. You only use the empirical rule when your data is both unimodal and symmetric. You do not use it for bimodal. You do not use it for skewed distributions. If you see that your distribution is unimodal and symmetric, then you can use the empirical rule to describe the spread of your data. The empirical rule says majority of your data lies within one standard deviation of your mean. To be more specific, that majority is 68% of your data. One standard deviation above the mean, one standard deviation below the mean. 68% of your data lies within those two values. 95% of your data, approximately, will lie within two standard deviations away from the mean. Now we know the mean is in the center, right? This is symmetric, so we said the best measure of center is the mean. So it's right here. Standard deviation, distance away from the mean. So 68% within two standard deviations, 95% within two, 68% within one standard deviation. Within three standard deviations, again, that means 3 below and 3 above. Within 3 standard deviations represent almost all of your data, approximately 99.7%. So that means anything outside of 3 standard deviations That's just the other 0.3%, because the entire curve has to be 100% of your data, because that's all of the data. Okay. So again, we use the empirical rule to describe the spread of distributions that are symmetric and unimodal. All right. If the distributions are symmetric and unimodal, there's one more thing that you can do, and that is calculate a z-score. A z-score tells you how many standard deviations away from the mean a data value lies. Okay, how many standard deviations away from the mean a data value lies. You will have to calculate z-scores, and this is the formula to do so. You will not be able to calculate it in your calculator. Okay, you have to use a formula. So the formula says take the data value you are interested in converting, subtract the mean, and divide by the standard deviation. So these numbers down here are z-scores. Remember, z-scores can be negative. That just tells you if it's below the mean. If it is, if it's above the mean, that means it's positive. Remember, your mean is located in the center. Okay. So these are z-scores. 1 standard deviation below the mean, 2 below, 3 above the mean. We like to use z-scores when we're trying to compare a group to another group. For example, if I were to make a comparison between the scores on the test in my online class to the scores in my in-person class, if you had students that wanted to make a comparison, you need to calculate a z-score. Okay, so whatever data value you are converting, the z-score gives you a standard score. So that means, hey, we're in different units, because I just said the online class versus the in-person class, those are different units. So if I want to compare, if you have two students that want to compare how they're doing, then they need to calculate their z-scores to determine how they're doing relative to other people in the same class. So the z-score standardized, it makes everything in the same unit.
I have a question.
Yes.
Is there a difference if the positive or negative?
Yes, we stated that if it's negative, that means it's below the mean. And if it's positive, it's above the mean. So for example, if the average score on the test was an 80%, and if I tell you that the standard deviation is 5, and let's say you scored a 70, well, I automatically know if the average is 80 and you score a 70, then you're below the average, below the mean. Therefore, you should have a negative z-score. Okay, so 1 standard deviation below the mean, that would mean to subtract 5, because my standard deviation is 5. 2 standard deviations would be at 70. So a person who scored a 70 on the test would be 2 standard deviations below the mean. And using the formula to do so, you would take the score that you're trying to convert, you subtract the mean, which I stated was the 80, and then you divide by the standard deviation, which is the 5. So 70 minus 80 divided by 5 is -2. All right, now let's use that empirical rule as well as the z-scores, make sure we have a good understanding. An exam has a mean of 80 and a standard deviation of 5. All right, didn't mean to use the same example, but okay. All right, what percent of students scored between 70 and 90? All right, 70 and 90. So assuming, because I clearly didn't state this in my instructions, all right, let's assume the distribution is symmetric and unimodal. I would definitely need to know that before I can answer this question. All right, so if it's symmetric and unimodal, I know I can use the empirical rule and I know I can calculate a z-score. Okay, so if the mean is 80, and we just did this, 1 standard deviation. Now at the mean, that would have a z-score of 0, because remember, standard z-scores tell you how many standard deviations you are away from the mean. So if you're at the mean, you have a z-score of 0. All right, so 75, that's 1 standard deviation below. 70, 2 standard deviations. 65 will be 3 standard deviations, and so forth. Above the mean, 85, 1 standard deviation above. 90, 2 standard deviations above. 95, 3, and so forth. So if I'm between 70 and 90, 70 and 90 represents 2 standard deviations away from the mean. And the empirical rule said 68% lies within 1 standard deviation of the mean, 95% lies within 2, and 99.7 are almost all within 3. Therefore, 95% of students scored between 70 and 90, because that represents 2 standard deviations away from the mean. 68% of students scored between what values? Well, 68% represents 1 standard deviation away from the mean. So I take the mean and I add and subtract 1 standard deviation. So 1 times the standard deviation is just 5. So that's what we did here, 75 to 85. So what exam score corresponds to a z-score of 1.3? Okay, so now I'm using my z-score formula. If the z-score is 1.3 and I'm trying to determine the exam score, where the exam scores are my data values. So that will be the x I'm trying to find. The mean was 80 and the standard deviation is 5. So this becomes an algebraic problem. I need some more space, so I'm going to, I'll come over here. So the very first step in solving for x is to multiply both sides by 5. You have to clear the fraction. So that gives us 6.5. And the 5s over here cancel. And the next step is to add 80 to both sides to get x by itself. So if you scored an 86.5, if you had a z-score of 1.3. All right. So we've just covered, whenever we're dealing with numerical variables, once we go into SOCs, we're summarizing, looking at our center and spread. The best measure for center and spread of a symmetrical distribution would be the mean and standard deviation. Okay. Again, I'll show you how to calculate everything at the end. All right, now let's talk about the median. The median is the number in the middle. The median is the best representation for a skew distribution. And we stated the IQR for the spread. So when you're looking at where your typical value is, and then which one's the best measure estimate of that typical value, which is your mode, if your distribution is skewed, you see that the median is closer to that mode. Even over here, with a left skewed distribution, the median is closer to the mode than the mean is. So that's why we use median to represent the typical value of a skew distribution. The typical value represents the center. In a symmetrical distribution, all of these, if it's perfectly symmetric, then all of these are the same, or practically the same. They're very close. Okay. If you're ever confused on the shape of the distribution, if you're really not sure if it's skewed or symmetric, you can compare the means and the medians. If the mean is greater than the median, you have a right skewed distribution, because the mean is going to pull in the direction of the tail. What's in the tail? Possible outliers. Okay. But if the mean is less than the median, you know your distribution is left skewed. And if they're practically the same, so I'm going to say approximately, you know that they're symmetrical. Okay. So I always tell my students, if you ever get confused, you're not sure what that shape is, then look at the mean and the median and make a comparison. Okay. Okay. Let's do our calculations. I will start with the calculator. So for those using your calculators on your test, I'll start with showing you how to do all your calculations, and then we'll go to the Stat Crunch. So if you have my Stat Lab, you can use Stat Crunch on your tests. Well, you gotta have my Stat Lab. That's where your work is. All right, but everyone has access to Stat Crunch. So it is a very good, useful tool for you if you want to use that. Okay, so let's enter this data into our calculators or Stat Crunch, wherever you're going to complete the data. If you need reminding of how to do so, give me a second. Let me split my screen, and then I'll reshare so that I can show you how to enter this into the calculator. Okay, you should be seeing the data as well as the calculator. Okay, so to enter your data in the calculator, you go Stat, and then press Enter on Edit. So you have a bunch of lists here, so just enter your data in one of the lists. You always want to look over your data, make sure it's correct, because you can always make mistakes. And if you make mistake on entering your data, then just about everything is going to be incorrect after that. Okay, all calculations would be incorrect. So be careful there. All right, the next thing is, how do you visualize? Once you enter your data, remember you need to classify it. These are numbers. It doesn't state that it represents a particular category, so therefore numerical data. So now what type of graphs can I create with numerical data? Dot plots, histograms, and stem and leaf plots. In your calculator, the only one you can create is a histogram. All right, so all your graphs are under stat plot right there. So it's blue, so I'm going to go second and y equals. Press enter, make sure it's on. You only want to have one of these plots on. If you have more than one on, the graphs will overlap. All right, we're going to scroll down, go over to the histogram, press enter. Right here, it's asking you, where's your data? So my data was in list 1, the data I just entered. So right here above the numbers 1 through 6, you see all of your lists. So list 1 is above number 1, it's blue. So second and the number 1. From this screen, to see your histogram, you press zoom and the number 9. All of these steps are in your calculator module. There's a document that gives you all the steps. It doesn't matter which class you're in. We kind of, some of them copy my shell, and I know what's in my shell, so you guys should be getting the same thing. All right. You have also the YouTube channel where we give you, we show you how to do all of the calculations and how to use your calculator, as well as in the modules themselves, there are short videos that will show you how to do this as well. Okay, so looking at that data set, all right, here's we have some a skew distribution. All right, so because it's skewed, the median and the IQR is going to be the best measures of center and spread. So now how do we do our calculations? All of our calculations, you go back to stat, scroll over to calculate, press enter for one variable statistics because you just have one variable. Once again, where is your data? Again, my data was in L1. And then let's calculate. So whether you have an 83 or 84, these steps are very similar. In the 83, you won't see it listed in this manner, but you can just press enter and you get the same answers. So there's our mean X bar, 37.2. Here's our standard deviation, S of X, 38.05. And if you scroll down, you get your 5-number summary, which includes your median, your Q1 and your Q3 that represents your IQR. Okay. All right, so let me write down this information, and then we are going to determine how do we calculate outliers, and let's do that median and IQR as well. All right, so let me go ahead and show students on StatCrunch while we're here. So what should you do in StatCrunch? 1 second again. Okay, so you can go to you can go to statcrunch.com and enter in your Pearson information, or you can log in. Whoops. You can log in. I'm sorry, this my StatCrunch is. Okay, let's try that again. All right, you can log in through Canvas, go into your home page for Pearson, not through the assignment page. Okay, if you go through that home page, then it will allow you to enter into StatCrunch over on the dashboard. Okay, so now let me show you all where I'm at. Now that I'm here. Okay, so once you enter your data, so this is the same data that I just entered into the calculator. Then to see the graph, because you know that's the next step, you have to visualize it. We need to know the shape of that data. So you go to whichever graph you want. Now you can see in StatCrunch, you do have the option to do the stem and leaf plot, and you can also create your dot plot. Okay, but histogram is very common, so that's why I'm selecting histogram. Then you select where your data is located, and then you compute. There's some other options in there, but right now we don't really need those. Okay, so here's our distribution, which was very similar to what we saw in our calculator. So now that I can see, okay, yeah, that's going to be skewed, and we might have, you know, another mode there that we really didn't see in our calculator. It wasn't very obvious, but now we can see that, hey, there's a possible or a bimodal, another mode. All right, so now that's how we graph. Now let's take a look at our calculations. You go to stat, summary stats, columns, because your data is in a column. Again, select your data. Oops, didn't mean to select those. And compute. So this is where all of your calculations for module 3 can be found, right? So here's your mean. There's the standard deviation. There's your median. Right, and then we have our 5-number summary, which is your minimum, your Q1, your median, then Q3, and then your maximum values. Now in the calculator, it says it just like that. Yeah, it gives it to you in that particular order, but not in StatCrunch. You would have to, sorry, you guys can't see the calculator. I pulled it up on the screen, but it's not showing for you. All right, you would have to put it in order to get that 5-number summary. Okay. All right, so let's go back to the problem now that we have our calculations. Let's make sure you're seeing, okay, you're not seeing what I'm seeing, so. Okay, so you should be seeing the PowerPoint now. So since our distribution was skewed, then the median, which was 16, the median is the best representation for our typical value in this data set. The IQR is your third quartile minus your first quartile. So here was my 5-number summary. And again, it's in the order of minimum, Q1, median, Q3, then maximum value. Okay, so your Q3 was 83 and your Q1 is 8. So that has a range of 71. So I'm calculating this to determine if we have any outliers. So the outliers, we want to use what we call the 1.5 IQR rule. This rule says that you take your Q1 and you subtract 1.5 IQRs. Any number that is smaller than this number, any data value, so you have to look at your data, any data value that's smaller than this number is a possible outlier. Okay. That's called the lower fence. The upper fence says you take Q3 and add 1.5 IQRs. Any number larger than this number is a possible outlier. Okay. So let's do those calculations. My Q1 is 8. 8 minus 1.5. We calculated IQR right here. Okay. So when you do that calculation, any number smaller than this number is a possible outlier. All right, so let me do that calculation quickly. All right, so that's going to give us, oops, a negative 98. We don't have any negative data values in our data set. Therefore, we do not have any extremely small outliers. Right now, we check our upper fence, Q3. Q3 is 83 plus 1.5 times your IQR. Okay, so that gives us 189.5. Any data value larger than this number is a possible outlier. When I see my data values, I do not see any numbers smaller than negative 98 or larger than 189.5. Therefore, We do not have any outliers in this data set. Okay, Hannah?
Hi, I'm confused on the IQR. Because when I did it in my calculator, I got 75.
And you are correct. I inverted the numbers, so thank you very much. All right,
So I have a
let's
question.
make those numbers even larger, so let me update that. Those answers, sorry. $75, okay. So these will be your fences. Okay, so they ask you for your lower fence and your upper fence, and then you look at your data to determine if you have numbers smaller than this one or larger than this one. If you do, you would say, hey, these are my possible outliers.
So I have a question.
Yes.
I'm still learning how to use both StatCrunch and the calculator. And I think for me to reduce anxiety, I just need to focus on one or the other. And I think that for me, StatLab will be easier to learn. I know I risk, like you said in class, I risk technology not working during the exam. And I'm willing to take that risk. My question is, I know there's videos or tutorials on Canvas about the calculator, but I'm not finding any about StatCrunch.
Okay, so in my course, now if your instructor copied my course, you'll see my StatCrunch videos in the modules.
Okay.
If you go into module 3, I stated it's StatCrunch videos, module 3, or whatever the topic is. You will see them under that particular module. So in module 1, is there anything in StatCrunch we did in module 1? Nothing more than entering data. So I think I didn't start StatCrunch videos until module 2, if I'm not mistaken, where I showed you how to create the graph. And then in module 3, I showed you how to do these calculations. Yes, StatCrunch is a lot easier, but this is for everyone. If you have trouble using HonorLock and StatCrunch, again, contact the HonorLock agent via chat. They will send you a link so that StatCrunch will open and work for you.
Thank you.
You're welcome. Okay, let's take a look at, oh, I don't think we finished. All right, let's summarize this distribution. We looked at the shape earlier. We saw that the shape was right skewed, and I believe it was bimodal, if I'm not mistaken. All right, so the distribution of whatever this data is, just something that I made up, is right skewed and bimodal. And it didn't have any possible outliers. So, you know, I'm going right through SOPs, shape, right skewed, bimodal, outliers, none. You're going to have to show your fences to determine outliers. What's the best measure of center? Well, because it was right skewed, the best measure of center is the median. So that represents our typical value. And then spread, the best measure of spread is the IQR, which represents the middle 50% of the data. So I would say, let's say this represents how many, oh gosh, I can't even think of something that's spanning from 4 to 98. How much money someone has in their pocket. Okay, so I would say, well, typically a person has $16 in their pocket because that's the median and it represents the center. And remember in module 2, we were talking about, is the center the typical value? Then I would say with the middle 50% of people having between $8 and $83 in their pocket, because that's my IQR, okay? The Q1 and the Q3. You can also say it has a range. The middle 50% of people have a range of $75 in their pocket. So either between 8 and 83 or a range of 75. Okay. All right, now let's compare box plots. So the same way that you can create a histogram in StatCrunch under graphs, you can go in there and create a box plot. I showed you all how to create it, or, reminded you where to go to create a graph in your calculator. There's a box plot there as well. So if you ever want to take a look at the box plots and compare them, then you can just go and look at the graphs. Now, box plots are best used for unimodal distributions. A box plot does not give you the mean. It does not give you standard deviation. So therefore, you only want to use them when it's best for your set of data and you want to create something that will allow you to visualize. But again, it's only giving you medians. It's giving you your 5-number summary because that's how we create the box plot. It's based upon the minimum, the 5 numbers that we were just looking at, Q1, the median, Q3, and the maximum. Between each of these numbers represents 25% of your data. Remember, by definition, the middle 50% of your data is your IQR, Q1 to Q3. So if I'm asking you about the spread of the box plot, you look at the box. If I ask you about the center of the box plot, that line, vertical line in the middle of the box, that's the median. Again, the box plot tells you nothing about skewed or, I'm sorry, not skewed, it's not what I meant to say, means or standard deviation. It doesn't tell you about modality. We have no idea if it's a bimodal, unimodal distribution, but like I said, it's best used for unimodal distributions. And it's best used for data when you have a data set that has more than 5 numbers. Okay. All right, so some of the questions that can be asked here would be center, compare their centers. So if I'm comparing their centers, there's only 2 measures of center, mean and median, and the only thing that the box plot gives you is the median. Therefore, if I compare their centers, I'm going to say second period has a larger center than first period does. Okay, because second period's at 85, let's say these are test scores. So therefore, typically second period scored higher than first period. Because again, remember, typical is my center, the typical value. My typical value is represented by the median in this case because that's all I have. So typically second period is greater than first. Now, if I ask you about the spread, again, the only spread that you're given in this box plot is the IQR because standard deviation is not given. So which one has the greater spread? We talked about it earlier. If you want to look at spread, you are looking at the box itself. So when I compare these boxes, first period has a greater spread than second period. Neither one of them have outliers. Okay, because you don't see any outliers indicated.
Working on yourself like a girl. That's not a derogatory thing. That just means you're doing the wrong things. If you want to become a top 1% guy,
Can we mute, please?
you need to do. The first one will surprise you, and it's status. Status literally just means how respected you are in the world.
Thank you. All right, and finally, what do we do when our distributions are bimodal? This is a bimodal distribution because it has 2 mounds. It's numerical. You see, it's test scores. So the mounds don't have to be the same height, but for numerical distributions, right? But because it has 2 mounds, we have a bimodal distribution. Now, what do we do with this type of data? For a bimodal distribution, a lot of times it represents 2 subgroups. So maybe there are 2 different groups that are part of the study, because if I'm randomly selecting, I should get a little bit of everybody, right? So if these are my test scores, then maybe this group of people didn't study and these did. So anytime you have a bimodal distribution, it is good for you to separate the data. So separate the data based upon their mounds. So didn't study, did study, they're both roughly symmetrical. So now if I compare them, since they're both symmetrical, I can compare their means and standard deviations. because that represents the center and spread for symmetrical distributions. But if one of these were skewed, if I was trying to compare a symmetrical and a right skewed distribution, I will compare them using the medians and IQRs. So the rule of thumb again, if you have a bimodal distribution, that may be a sign that there are two different groups included in the study. If you split them and you're now comparing two different shapes, then you have to compare their medians and their IQR. If you're wondering why can I not use the mean? For one thing, you can't compare means to medians. That's one thing. You have to compare mean to mean, median to median. So if the shapes are different, remember one thing that I taught you about symmetrical distributions, and I apologize for this red, is that the mean and the median are practically the same in a symmetrical distribution. At no point will you use the mean to represent a skew distribution center. I showed you earlier that the mean is going to pull in the direction of the tail because the mean is affected by outliers. So therefore, since the median is very close to the mean in a symmetrical distribution, when I'm comparing these two of different shapes, I'll use the median. And whenever I use median, I must use IQR. They go hand in hand. Same thing with mean and standard deviation. Okay. All right. So some things I went into a little bit more depth than others. Like we were kind of doing a lot of the definitions to start with. But we had an hour and a half, and there's no way I can teach you 3 modules in depth in an hour and a half. So hopefully this was helpful. If you have any questions, we have 3 minutes left. I'll go ahead and stop the recording and you can stick around for questions. But otherwise, I wish you the very best on your upcoming test. Please reach out to your instructor for specific instructions and further help. All right. You all have a wonderful evening.
Thank you.
Did we answer? You're welcome. Did we answer, Mr. Petit? Were all questions in the chat answered? I haven't had a chance to look.
Okay, I think there is one. Would this be a good example of something we might see in the test, but I don't know what this refers to. And the question that I answer is this one. And I think a student asked if they have to be symmetric to calculate the z-score. And we can calculate the z-score. But this one say yes because he used standard deviation and mean for symmetric data. And we use standard deviation and mean for all type of distribution. However, the empirical rule works for symmetric and approximated normal distribution.
Mm-hmm. Yes. Okay, so you've already answered everyone.
Mm-hmm.
Okay, awesome. Okay, good. All right, so is there anyone left that has any questions?
My question is, when using like a handheld calculator, I couldn't find where it said quartile 1, quartile 3. I couldn't find the list of like where the median is and things like that.
Okay, are you using a graphing calculator?
Yes.
Okay, so let me share the graphing calculator again. Let's go find it. Okay, so we went to stat, calculate, press enter on one variable statistics, calculate if you have the 84, and if you scroll down, there's where your 5-number summary, your median, etc. is located.
Okay. So it's under the one var stats,
Correct.
pretty much. Okay, thank you. That was
You're
all I
welcome.
needed.
All right. All right. Any other questions quickly? We're at time.
Yeah, I had one question, not so much about the PowerPoint, but I came to you earlier in your office about my login for Pearson. And
Okay,
I
hold on,
tried
hold
to
on.
get
One
yeah.
second. Is this a personal question?
I mean,
Because
nothing.
this session is being recorded, so I don't want to.
No, nothing the world can hear. Like it's not. It's just like, I know the homework is due tomorrow. And like one of the people, they weren't able to help me because like they close at 5.